I guess it doesn't really matter, but I feel better about it, and that's all that really matters to me, that I feel better about it, okay? Oh, somebody asked me what kind of dogs I have. I have a German Shepherd, I have a Corgi, and I have what people tell me is a Chiweenie, but I don't believe it's a Chiweenie. So, yeah. Say again? Oh, yeah. I'll show you later. I'll show you in a second. This is Kovu, the little Chiweenie, whatever people call him, Chiweenie. He's the cutest little guy. So, and Yogi, he's a curmudgeon now. He's still old. Me and my girlfriend got Yogi back in like 2017. He's a curmudgeon now. All right, let's get started. So where we left off last time, there it is. I was like, where's my pen at? Where we left off last time was we were talking about scientific notation, okay? And so let's go ahead and start talking about scientific notation. Have your phones out. Be prepared for answering questions, okay? The first time, again, obviously, you're going to have to log in maybe, right? Make sure that you're already logged in the Texas Wesleyan Wi-Fi so it doesn't ask you to log in again, okay? I'm warning you right now, there will be multiple questions today, so just make sure you have your phone ready. I'll wait for you guys to get your phones out. It's weird when the prof tells you to get your phones out, right? Okay. Ooh, dang. Sorry about that, whoever that was. You know what? I'm going to move over here so you can see that screen better. Maybe I should do it that way. There we go. That's better. All right. Everybody got their phones ready? Everybody ready? All right. Let's go. So the question here is, how do I get good at science, right? And really, the way you get good at science is by studying, practicing, and being really good at math, okay? Being really good at math. So let's do a quick math review, right? And scientific notation is a part of that math review, okay? And a lot of this might sound very rudimentary, very like high school, but we need to make sure everybody's on the same page about this because your exams and a lot of the stuff coming afterwards will deal with a lot of regular algebra, and I need to know that everybody's at algebra level, okay? Everybody comfortable with algebra, right? With some X's and some Y's, okay? That's all right if you're not. That's what this is for, okay? It's okay if you're not. All right, so let's start out really, really back there here. Let's first talk about decimal places, okay? We have decimal places, okay? So if you have a number like 2,500, 18.407 grams, a number like that, right? The 8 here is in the ones place, okay? The 1 here is in the tens place, The 5 here is in the hundreds place, and then the 2 here is in the thousands place. That says thousands, I promise. Thousands. I promise that says thousands, okay? And then the 4 that's right behind the decimal point is called the tenths place with a TH. And then the 0 is in the hundredths place. What the heck is happening with my pen today? Hundredths. Okay, hundredths place. All right, and then the 7 is in the thousandths place with a TH at the end. All right. You need to make sure you know all those decimal spots. So that brings us to talking about scientific notation. Why are you being so hard right now, pen? Like, you're writing really slow. Scientific notation. So if you have a number like 2400, not 20y100, but 2400, you can put that in scientific notation easily, right? By moving the decimal point from the ones position to the tens position to the hundreds position, like that. And this becomes 2.4 times 10 to the third. Okay? 2.4 times 10 to the third. If you have a number like 0.00086, you can move the decimal point from the ones position to the tenths, hundredths, thousandths, and 10,000ths, right? And you get 4 spots moved, right? 4 spots moved. So you get 8.6 times 10 to the -4. So the exponent is quite literally the number of spaces you move, right? In the to get it to the position where the number is around the decimal point. Okay. So this rule is called the power of tens. Look, I have no idea why my pen's acting so crazy. Give me 1 second here. I'm going to disconnect it real quick. Let's try it on this side. Maybe that will help. Well, maybe it's because it's upside down. All right, let's try it now. Power of tens, or... Nope, that didn't help at all. Tens. There we go. Okay. So what the power of 10 says is that if you have a number like 1,000, what the heck? Why are you not writing? Right? If you have a number like 1,000, what that actually equals is 10 times 10 times 10. It's probably good for you that I'm writing so slow so it would actually work because you can keep up. Otherwise, I'd be going really fast. And that equals 1 times 10 to the third. All right? 1 times 10 to the third. But if you had a number like 0.001, really, that's all that came up? 001. You can do it. Come on, Apple Pencil. You're supposed to be better than this. Okay? What that actually equals is 1 over 10. What's the problem? This right here? This is power of tens, or tens, the number 10 with an S. It's not my fault, I promise. The Apple Pencil's acting crazy today. But I want to write it on here so that it's on the video when you guys watch it later. Okay, so 1 over 10, or 1/10, times 1/10. It wasn't doing this bad last time, was it? I don't think so. So weird. times 110 1 over 10, there we go. And then that equals 1 times 10. Oh, maybe I should just press down harder. Oh, that's what I should do. Press down harder. To the negative 3. Oh, that didn't work. That's a negative 3, not negative 1. There we go. Okay? So that's called the power of tens. All right? That takes us to talking about positive. I'm like writing so much and nothing's coming up. Positive. Are you serious? Are you really that? Come on, man. Come on. Come on, man. Okay, this is not working. I'm going to have to restart my iPad because this is just acting nuts here. Why are you acting so crazy, iPad? You were just working in the previous class so well. So well. And of course, it's going to take like 10 minutes for it to actually start up. I blame Juan for being late. But I guess I could blame the twins. They were even later. Oh, wow, that actually started pretty fast. See if this fixed it. That's so weird. It's not responding at all now. Oh, maybe it's because it has so many apps open. Maybe I should just close some apps. Oh, that's why it wasn't working. The battery on the pen was dying. Rat? Yes, okay. You know what? I'll just use my finger then. Okay. So, that takes us to talking about positive. It's still not working. Of course not. Okay, I'm sorry. We're going to have to just do it on the board because the nothing is like working here. I have no idea what's going on. I almost want to just cancel class and let you watch a video. No, I wish. They have very strict rules now about, people doing. No, the pen is fine. The pen is fully charged. What the heck? Okay, maybe it's okay now. Okay, does everybody have all that stuff written already? Because I'm gonna have to erase it now. You ever got that stuff written? Okay, so that takes us to positive. Oh, it's back. Oh my God, that's crazy. Positive / negative numbers. See, that's how fast it's supposed to be going. That's crazy. Okay, so when we're talking about positive and negative numbers, we got 0 there. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, which is negative numbers. And what I want people to do here is when you subtract and add positive and negative numbers, I don't want you to use the words plus and minus, but I want you to use the words combining, okay? Combining numbers. And what I mean by that is this, okay? Say you have negative 6 plus 3, right? Negative 6 plus 3, and that's a negative 6 inside parentheses, okay? Plus 3. What do you get? Combine negative 6 with positive 3, and you get what? You get negative 3, okay? Or, say you combine negative 6 what? Yeah, that's a negative 6 inside of a parentheses. Oh, I apologize. My 4s look like 6s, I guess. Okay, so negative 6 again, right? Plus negative 3 this time. So now we're combining negative 6 with negative 3. Before we were combining negative 6 with positive 3, right? This time negative 6 with negative 3, what do we get? Negative 9. Okay? Or we can combine positive 6. Wow, I wrote 6 backwards there. Weird. We can combine positive 6, right, with negative 3. And now we get positive 3. So I don't want you to, sorry, I forgot to put a plus sign in there. I don't want you to say 3 minus 6 or negative 6 minus 3 or something like that. I want you to say the charge of the, not the charge, but the positive or negative of the number combined with the negative or positive number, right? So negative 6 combined with 3 makes negative 3. Negative 6 combined with negative 3 makes negative 9, right? Positive 6 combined with negative 3 makes positive 3, okay? That's what I want you to do. All right, so let's put this into practice with some rudimentary math, right? So this is one of the notes pages that I forgot to put in the newest edition yesterday. So I put it on today, but if you didn't print it out today, then you didn't get it. And that's why I passed it out to you. So I don't know about you guys, but I've been taking a lot of Sudafed so my nose doesn't run and people don't think I have COVID, right? And I noticed on there that, did I bring my laser? Where's my laser? Oh, it's in my pocket. I noticed that there's only 120 milligrams of Sudafed, the molecule, in this pack right here, right? 120 milligrams. Which Sudafed is the same thing they used to make crystal meth, by the way, right? But when I weigh the tablet says it is 0.7 grams. 0.7 grams is the same thing as 700 milligrams. So very little of this pill is actually the active ingredient that you're paying for, right? So the question is then, what percentage is actually Sudafed, right? Well, that's super easy because you know what you have in the pill, which is 120 milligrams. You can divide it by the entire weight of the pill, which is 700 milligrams. Multiply that by 100%, right? And that will give you what percentage of that pill actually is the active ingredient, okay? And that actually comes out, you can do it on your calculators if you want, but that actually comes out to 17.1%. So less than a quarter of that pill is actually what you're paying for in Sudafed, okay? Good stuff. Let's keep on moving then. Oh, question. Go ahead, scan it and answer it. Everybody get your phones out, scan it, and answer it. Make sure you're on the Texas Wesleyan Wi-Fi so that you don't have to log in more than once. Okay? You have this number. What is it written in scientific notation? Make sure you do this question because this will be your attendance grade. All right, let's see where you are. Anybody having a problem logging in? Any problems logging in? Okay. Let's see how many people have answered so far. "24 responses already. Wow. Is that everybody? Do we have 20? I thought we had 26 in here. Don't we have 26 in here? Oh, you are? You're still trying again? Let me see what's going on. What's your username and password? Yeah, type it in again. Try to type in your username. The same thing that you used to get into the laptop. Yeah, so we're missing one person. All right, we can go ahead and look at these responses real quick. Let's see what everybody answered so far. What the heck is that? That's all right. I'll just look over here for now. And we'll go back to that in a second. Okay. Oh, wow. Okay. A vast majority of you voted for letter C as the answer. Yeah, let's see here. See if you're right. Because I don't remember what it is. Yes, you are correct. Letter C is, in fact, the answer. You have to move the decimal point 8 times, and you're going backwards, so it's -8. Good job. Okay, good job. Good job. All right, let's keep going. Did you get yours in yet? Did you log in? Yeah. Good. Did you answer the question? Yeah. Good. Because we need to make sure that you've logged in for your attendance. All right. Let's keep going then. So many people made that right that I don't have to make you guys discuss it with your group. Okay? All right, so let's talk about solving equations now. Just regular old solving equations, okay? Say you had an equation like, and of course that's what happens because I forgot to change it back to drawing. So say you have an equation, 2x plus 8 equals 14. Okay? How would you solve for x in this? Quite simply, the first thing you would have to do is subtract 8 from both sides. Right? Because your goal here is to get x by itself. Okay? So 14 minus 8 is going to be what? Right. And then you still have 2x over here. So 2x equals 6. All you have to do now is divide both sides by 2. You do everything you did from one side, you do the other side, and now x equals 3. Okay? So one of the most used equations that we use in chemistry is this thing called the ideal gas law. The ideal gas law, and it is PV equals nRT. Okay? The P stands for pressure. pressure. That pressure is always going to be in the unit of atmospheres. Okay, the unit of atmospheres. The V stands for volume. Okay, that will always be in the unit liters. Okay, unit liters. R is something that we call the ideal gas constant. And that is a constant that you can look up that will always be the same. You don't really need to know it, but it is 0.0821, right? So every time you see an R in chemistry, you put in that number, 0.0821, okay? The other thing here, T, is temperature. And temperature will always be in Kelvin. Okay, temperature will always be in Kelvin. And the last thing here is N. N stands for the number of moles. Of something, okay? The number of moles of something. Whoops, sorry, Siri. The number of moles of something. So what is a mole? In chemistry, a mole, right, is kind of like a dozen, okay? So a dozen means you have 12, for example, a dozen eggs, right? There's 12 eggs. But in chemistry, a mole is actually this number here. 1 mole equals 6.02 times 10 to the 23rd atoms. Right? So that's a really, really big number, right? That is 6 with 23 zeros behind it. That's a lot of atoms, okay? So that's something that we call Avogadro's number. I always have to spell it out slow. Avogad. But now my pen is working slow again. Gadro's number. So Avogadro's number is also a constant too. Okay? So what I want you to really get out of this is that when we have an equation like PV equals nRT, we can solve for any one of those variables because science is about variables, right? So we have PV equals nRT, and say you want to solve for the pressure. How do you solve for the pressure? Easy, right? All you do is divide both sides by what? V, exactly. And so now, P equals nRT. What the heck? Sorry, I got to disconnect again. It's acting crazy. Okay. RT over V. What the heck? V. Okay. Or say you wanted to solve for the number of moles, for example. So PV equals nRT. How do you solve for the number of moles this time? Right, divide both sides by RT. right? And so then you end up with PV over RT equals what? Number of moles, okay? So you're going to be doing that a lot in class. You're going to get this equation, and you're going to have to solve for different parts of it, given that you have other parts, right? All right, other variables. So let's keep trucking along. I'm very upset that my pen's acting crazy. So let's quickly talk about the phases of matter, all right? There are three phases of matter, the solid, liquid, and the gas, right? And the important things to note about the phases of matter is that solids have a very definite shape, right? This table it's solid. It has a very definite shape. It also has a very definite volume, too. You can measure the 3 dimensions of this table, and you'll know the table's volume, right? The other thing to notice, too, is that the reason why they're so solid is because their particles, the atoms and the molecules that make up the table, are very fixed and close to each other, right? And the interaction between those molecules and atoms are very strong, right? That's why it's so hard for you to break through this laptop part to steal a laptop, because it's made of very closely and very strongly interacting molecules and atoms, right? And so that means that when it's very strongly attached to each other, very fixed and very close, that means the particles moving inside the atoms and the molecules, they're moving super, super slow. So good examples of that would be ice, salt, and iron, okay? Liquids, though, they take the shape of their container, right? Like that bottle of Purell right there, this bottle of Purell right there, it's a liquid, and it takes the shape of that bottle, okay? Also, so it has a definite volume, because you can measure that volume, right? I'm guessing that's like maybe a liter of Purell in that bottle, that hand sanitizer. They're very random, but they are close to each other. They have strong, not super strong, but strong interactions. But the movement is kind of moderate, right? And if you look at a bottle of Purell or hand sanitizer, the movement is definitely very moderate because it's like very thick, and it takes a minute for it to pour. Whereas it's very viscous, right? Whereas you just had regular water, it would just flow with no problems, right? And so examples, of course, are oil, vinegar, water. And lastly, the gas. The gas takes the shape of the container, like quite literally. If it's in a balloon, it'll take the shape of the balloon, right? Fills the volume of the container, which is different from the other two because the other two have definite volumes, right? Random and far apart. That's how their atoms are. That's how their molecules are, right? Random and far apart. There's essentially no interaction between these molecules or these gases, They're moving very quickly, and an example of those would be water vapor, helium, and air, okay? That chart is in that paper I gave to you just now. So you don't have to write any of that down because I gave you a printed copy. So answer this question now. All right, what number are we on for the questions here? This is the one about which phases of matter consist of particles that are random and far apart. That would be oh, wow. 24 people have already responded. Very quick. Very quick. And 25. And I'm happy to say that the vast majority of you, right, got it correct. It is the gas. I don't know what to spell there. It is the gas. So good job there. I don't have to make you talk about it in your groups. I'm sure you want to talk about it in your groups. All right, but that's okay. All right, good. So let's keep moving. Keep on dropping stuff. I told IT that I want to have a button here so I can press back and forth between my laptop and the computer on the screen. and they still haven't responded to me, so I'm going to have to file a complaint. Anyway, see, I was supposed to make you do it as a group, but you guys already got it all right. Good job. So let's talk about graphing, and we'll use gases as an example, right? We'll talk about graphing and use gases as an example. This is very important right here. So on a graph, okay, the x-axis is known as the independent variable. Okay? The y-axis is known as the dependent variable. And that's important because the x-axis or the independent variable is always something you cannot control. Okay? For example, here, the temperature is something here, right? The temperature goes up, you can't control it, right? It's getting hot outside. Can you control that? No. Okay? But the dependent variable is the thing that depends on the independent variable. So here, what you can see is that as the temperature increases, the gases inside the balloon increase in volume, right? They get bigger and bigger and bigger. This is known as a direct relationship. Right? It's known as a direct relationship. If the line were going this way, it would be an inverse relationship, correct? Right? So if it had an inverse relationship, what you say is, as the temperature increases, the volume decreases. That would be the inverse relationship, right? Okay, so let's talk about parts of this graph. Okay? So the first thing to note is that the graph has a slope, right? The line on the graph has a slope. And each point on the graph has an x and a y coordinate. Okay? You'll have to be making graphs in lab. So this is why we're doing this now, so I don't have to teach it to you again in lab. Okay? X and y coordinate. Okay? There's also this thing called the y-intercept. It's where the graph crosses the y-axis, right, at 0 on the x-axis. Okay? At 0 on the x-axis. So, every line on the graph has this thing called the equation of the line. Equation of the line. And the equation of line is this. It is y equals mx plus b. Okay? It's y equals mx plus b. The b right here is the y-intercept. Okay? The m here is the slope. It's the slope, right? And the x and the y are self-explanatory. They're these parts right there, the two coordinates of x and y, right? Everybody got that so far? So it turns out when you have this kind of information, you have a picture of a graph, right? You can figure out a lot of things about this graph, okay? And the key to figuring out a lot of things for this graph is solving for the slope first. Okay? How do you solve for a slope? Does anybody know? You have a line. You have some data points there. How do you figure out what the slope of that graph is? Yes, rise over run. Exactly. So m equals the change in y over the change in x. Okay? And that equals what someone out there already said, which is rise over run. Rise over run. Okay? So what do they mean and what do I mean by rise over run? Rise is how high up you're going the y-axis, and run is how far to the right you're going onto the x-axis. Okay? That's why it's a change in y over the change in x, or rise over run. So, does anybody know the equation then to figure out what the slope of the line is using points on the graph? Exactly. M equals y2 minus y1 divided by x2 over x1. We need to make sure everyone knows how to do this from this day forward, okay? Always remember, too, whenever you have something called the change in something, you have this capitalized delta, the Greek letter delta, right? And when you do that, it's always going to be the final reading minus the initial, right? It will always be something 2 minus something 1. It will never be something 1 minus something 2, okay? It's always got to be the final thing that you had, right, subtracted from the initial thing you had. So let's pick a point or two here. Let's pick this one, the one I had already right here. Okay? Let's pick that one. That's xy coordinates are what? 20 and 40, 20 and 24, right? So m equals, right? This is our initial right here, or y and x1 right here, okay? So y1 is 24, and then x1 is 20, right? Put that in first, okay? Now we need to pick another point. I'm going to pick this one right here. Pretty easy to see where that point is, right? On the y-axis is at 28, and on the x-axis is right between 60 and 80, so that's 70. So your y2 will be 28, and then your x2 will be 70. Okay? Some quick math tells you that this will actually be the reduced value, right? Well, I won't reduce it yet. The actual value is 4 over 50, or 4/50ths, right? So what do you have to do with every fraction you ever encounter? You've got to reduce it, right? The most you can reduce this is dividing both sides by 2. And so your final answer is going to be, for the slope, 2 over 25. Okay? That 2 over 25 here, that's what goes in there for m. That means that on the y-axis, you're going up 2 for every 25 times you're going over on the x-axis. Okay? So now your y equals mx plus b graph says this. Y equals 2 over 25 x plus b. Okay? Now that you have that, you can figure out anything. So let's figure out what the pressure would be then at the y-intercept, right? Because you can't really tell where the y-intercept is. It's slightly above 22 right there, right? Slightly above 22. So how do we solve for the y-intercept then? What do we plug in? You can plug in any x or y value you want, right? That correspond with each other, okay? So we'll just use this one again because we used this one earlier, okay? The y here is 28 equals 2 over 25 right, multiplied by the x value, which is 20, plus b. Okay, plus b. Can you see that? I'll write it over here. This is the equation now. 28 equals 2 over 25 multiplied by 20, because 20 is the x value where the y value is 28. Oh, thank you. I'm so glad someone's paying attention. Should be 24. You're right. 24 plus b. Okay? So now all you have to do is subtract both sides with 25 over 2 over 25 times 20, and then you'll get what b is. Right? So let's go ahead and do that. We'll subtract it from over here to, I'm going to write that again, 2 over 25. Okay, I'm not going to write it again because it's not working. So I'll just go ahead and tell you, right, that the y-intercept then, once you've solved for this equation, b equals, and I'm going to tell you right now, one of my biggest pet peeves is when people answer questions that don't make any sense, where the answers don't make any sense, okay? This y-intercept right here is just above 22, okay? It's not above 24. It's not above 28. So your answer should be something like 22 point something, right? So make sure your answers make sense when you answer them. Anybody figured that out yet? Anyone solve that? The y-intercept is 22.4. Ah, come on, Apple. I'd call Steve Jobs if he weren't dead. I mean, wasn't he the one that, invented the Apple Pencil? 22.4. So the cool thing about that is, and I want you guys to do this now that you know that b equals 22.4, right? You can actually do this now where you have y equals, if I could ever freaking write it out, y equals 22 over 25 I promise that's a 5 right there, x plus 22.4. Come on, why is 4 so hard for you to write? What is up with this? There we go, 22.4. So that's your equation of the line now, okay? Y equals 2 over 25x plus 22.4. I want you to tell me then, what is the volume of the balloon going to be, okay? What is the volume of the balloon going to be at, say, 100 degrees Celsius? Because you can put in any x value now, right? You can put in any x value and solve for what the y value is going to be, okay? So let's say what is it going to be at 100 degrees Celsius? What's the balloon's volume? I don't know what it is yet, so I'm going to go ahead and do it on my calculator and see if you guys have the same answer as me. Work with your group if you have to. I want to hear an answer from every house. Work with your house. Come up with an answer. This will also tell you whether or not you're putting in your answers into your calculator correctly, or your work. Okay, I got my answer. Remember, all you have to do, literally, is plug in 100 in X and solve for Y. 30.4? What'd you guys get? What'd you guys get? Slytherin? Okay. Gryffindor, you still working? I know you guys are slow. Okay, good job. Good job, Gryffindor. All right. So what's going to happen then is I'm going to give you a graph, right? Just like this, and you're going to have to figure out things about that graph, okay? The same way that you just did it here. So don't ever say I didn't show you how to do it. All right, so let's keep on going now. Let's keep on going. Oh, wait, we can't. It's already 6:15. We're done.